Hi, I'm Dr. Cameron Sheeler at UAB Biotechnology program, and today we're going to look at this equation C1V1 equals C2V2 as it relates to preparing a cell concentration so that we can use to place cells inside a petri dish or a flask. C1V1. C1 is your initial concentration. V1 is your initial volume. We're going to hit this equation multiple times in multiple videos just so that you can see how we can use it in different ways. C2 is your final concentration. V2, that's the final volume. Let's just say you've harvested your cells and you have a nice big conical tube full of cells at a concentration after you've counted the cells. You've got 1.75 times 10 to the 6 cells per mil. In other words, 1.75 million cells per mil. And then you have to place a final concentration of 20,000 cells per mil, but we have, say, 30 different flasks that we want to put it in. I want to add 1 mil into each flask. Always make a little bit extra. So why don't we make enough for 31 mils? So to do that, I put 31 here. So this is the total volume we want. We want this concentration of cells, 20,000 cells per mil, such that when we take 1 mil out, we will actually be able to add 20,000 cells into the flask or petri dish. Look at this right here. That's 1.75 times 10 to the 6. Doesn't that kind of look like a concentration, cells per mil? That is. If we've got 20,000 cells per mil right here, doesn't that look like a concentration? It is, I already told you that. And we have a volume right here, 31 milliliters. This kind of already looks like our equation. C1V1 equals C2V2. This is our initial concentration. Here's a concentration here, C2. Here's our final volume, V2. What is missing? We want to know how much volume to take from here that will give us that. That's our volume 1. And that's what we're solving for. X is the unknown. We bring it over here. We got 20,000 cells per mil times 31 mils. Bring this over here, divided by 1.75 times 10 to the 6 cells per mil. This is something I always tell my students to do. Please, when you set up any type of equations, make sure it's in the right format. For us right here, cells per mil, hey, they cancel each other out. We're left with the volume. So this is the units that I'm expecting, some type of volume. So if I take 20,000 and multiply by 31, 20,000 times 31 equals, now we divide it by 1.75 to the 6 equals 0.354 milliliters. Another way of stating this is that we can convert this to microliters. So when you use your pipette mint, that you will set your P1000 to 354 microliters. Now what I'll do is I'll take 354 microliters out of my initial stock of 1.75 million cells per mil, and that's what we have right here. Take out 354 microliters, and I will put it in our volume of 31 milliliters. 354 microliters is not really going to change the volume that much, but if you have to, you would take out 354 microliters and replace it with the cells with 354 microliters. That way we're assured that we do have a 31 milliliter total volume. What I normally would do is I would actually place 31 milliliters in my tube, knowing that I want to put 354 microliters of this cell suspension in that tube. I will go in and just pull out 354 microliters and replace it with 354 microliters of my cell suspension. When I have this thing done, I can take 1 mil out and put it into petri dishes. I already told you that I want each of those petri dishes to receive 1 mil of 20,000 cells. So that's basically how I would set this up, and I'd place these in the incubator until we have to use them. Questions, suggestions on any topics you'd like me to cover, please send me an email. Thanks for watching. See you next time.